Now in this lesson we're working on simultaneous equations. The first one, solve the simultaneous equations 2x plus 3y equals 7 and 3x minus 4y equals 19. Alright, in terms of setting it out, we'll just write down the two equations and call them 1 and 2. Now we're trying to eliminate either the x's or y's by either adding or subtracting. Now they need to be the same size to do that. So 2x and 3x, well, they're different sizes. 3y and 4y, again, different sizes. So let's just concentrate. Let's go back to the 2x and 3x. What we're going to do is think of what could we multiply them by to make them the same. Alright, and the same is going to be 6x. We could make them both 6x. Alright, we'd need to times the top by 3. Okay, 2x times 3 will get 6x. The bottom one by 2 to get 6x. So let's look at the top one. We need to multiply that by 3. And we've got to multiply everything by 3, not just the 2x. So if we multiply everything by 3, we come up with 6x plus 9y equals 21. I'm just going to put a line through that one just to indicate, right, we've replaced that with a new one. Now the next one, we're trying to make that 6x to start with, so we need to double everything. So doubling, we get 6x minus 8y equals 38. Again, we'll just put a line through that. So when we're only ever looking at two equations at a time. So call them 3 and 4. Now, to get rid of these 6x's, we would just subtract them. Alright, so we're just going to say equation 3, take away equation 4. So we have 6x minus 6x, well that's nothing. Then we'll have 9y, and we're minusing minus 8y. So we've got minus 8y, that'll be plus. So we'll have 9y plus 8y, we'll get 17y. We'll put our equals underneath each other. And then 21 minus 38 is minus 17. So at this stage, if 17y equals minus 17, then divide through by 17, we get that y equals minus 1. Now at this stage, we have a y value. We also need an x value. So what we can do, we can just substitute that into any of those equations above. Okay, doesn't matter which one. But let's just say we substitute into equation 3. So we're replacing the y with minus 1, and we get 6x minus 9 equals 21. Need to solve that, so take the minus 9 over, becomes plus 9. So we end up getting that 6x equals 30. And then dividing through by 6, therefore x equals 5. Now a good technique then, not just to leave your answer like that, but you've got the x equals 5, the y equals minus 1, write it down as a final solution step. Excellent. The second one, you need to find the coordinates of the points of intersection of the parabola y equals x squared plus 8x minus 2 and the straight line y equals 2x plus 5. So again, we'll need to solve these simultaneously. Let's just write down the two equations, call them 1 and 2. Now, what's a little bit different, see they both equations have y equals something. Okay, y equals something else. So what we do is set them both equal to each other. In other words, we have x squared plus 8x minus 2 is equal to 2x plus 5. Now at that stage we have a quadratic in x squared, so we want everything to one side. Okay, that's already positive, so there's no need to move that. We'll just write that down. The 8x will leave, but the 2x will come over and become minus 2x. So we'll have 8x minus 2x, that's plus 6x. The minus 2 is going to stay where it is, but the 5 is coming over, become minus 5. So you have minus 2 minus 5, we get minus 7. And when everything's been moved to one side, it all equals 0. Now we have a quadratic equation there, so let's factorize two brackets, x and x. And we're after numbers that multiply to give minus 7, and they have to add to give positive 6. Well, those numbers would be positive 7 and minus 1. So solving the two mini equations, we've got x plus 7 is 0, so therefore x equals minus 7. Or our other answer for x minus 1 is 0, therefore x equals positive 1. Now, we wanted the points of intersection. So far, we've got the x values, so we need the y values as well. So we need to substitute into either of those equations. Doesn't matter which one, but you might as well always choose the easiest one. I think the second one's the easiest one to work with. So let's substitute into 2. So when x equals minus 7, when we substitute into equation 2, we get that y equals minus 9. When x equals 1, let's substitute that into equation 2, we get that y equals 7. So our final step then, therefore the points of intersection are, alright, they're the coordinates there, minus 7 and minus 9, we put them in brackets. or the other one is going to be 1, 7. So there we have it, 2 points of intersection for the parabola and the straight line there. Our third and final example, we need to find the coordinates of the points of intersection of the hyperbola xy equals 8 and the straight line 4x minus y minus 4 equals 0. So again, we need to solve them simultaneously, so we write them down in equation 1 and equation 2. Now xy equals 8 and 4x minus y minus 4 equals 0. Okay, we can't really add or subtract anything there, but what we need to do is try to make one of the things the subject. And in that case, we'll try to make y the subject. At the moment, it's negative y, so to make y the subject, we'd take it to the other side so it become positive. So what we're doing, we're actually rearranging equation 2. We've taken the negative y over, become positive y, and then the rest of it will just be 4x minus 4. Now at that stage, we'll call that 3, and let's just replace that with 2 there. Just put a line through that. We're not looking at that anymore. So we need to substitute 3 into 1. So in other words, our y value there, we're going to replace into equation 1. Let's see what we do. Let's just write the x down firstly. The y we're going to replace with 4x minus 4. It's very important, it's in brackets there, and it equals 8. So now let's expand the brackets there. 4x squared minus 4x, and that equals 8. And the 8 comes over to the other side because it's a quadratic. We want everything to the one side equals 0. And when it comes to the other side, it becomes minus 8. So we end up with this. Now what do you notice about that whole equation so far? Well, hopefully you can see where you could divide by 4 to simplify things. And if we divide everything by 4, we get x squared minus x minus 2 equals 0. So we need to factorize that. 2 brackets, x and x. Need numbers that multiply to give minus 2 and add to give, what do you think? Minus 1, okay? If you don't see the 1, we know it's there. So factors of minus 2, add to give minus 1, those numbers would be minus 2 and positive 1. So solving our 2 mini equations there, x minus 2 equals 0, so therefore x equals 2. Or if x plus 1 equals 0, we say x equals minus 1. So don't forget though, we need the points of intersection. So far we've got the x coordinates of those points. We need the y. And which equation would be best to use? Equation 3, that's right. So let's substitute into equation 3 firstly. X equals 2. Pop it there into equation 3, we get y equals to 4. And when we sub x equals minus 1 into the equation, we get y equals minus 8. So final step, our solution. Then the points of intersection are, alright, that'll give us 2, 4. The other one will give us minus 1, minus 8. Terrific.